Next topic, conditional convergence. A series sigma k equal to 1 to infinity uk is said to be conditionally convergent if sigma k equal to 1 to infinity uk converges, but sigma k equal to 1 to infinity mod uk diverges. Diverges. That is sigma uk converges, but it is absolutely divergent. That is sigma uk convergent, but sigma uk is absolutely divergent. So such series are called conditionally convergent series. For example, we take a series sigma k equal to 1 to infinity minus 1 power k plus 1 divided by k. So this series is an alternating series. And in the last video we showed that this series convergent. This series is convergent by alternating series test. Okay? Series test. So this series is convergent. Now, if we take k equal to 1 to infinity modulus of minus 1 power k plus 1 divided by k, this is actually equal to k equal to 1 to infinity 1 by k. But this series diverges. Therefore, sigma k equal to 1 to infinity minus 1 power k plus 1 k is a conditionally convergent series. Okay, so this is an example for conditionally convergent series. Now we will take another example. So this series, consider this series sigma k equal to 1 to infinity minus 1 power k plus 1 into k plus 3 divided by k into k plus 1. So we used alternating series test to show this series converges. So this convergence of this series we already done uh, in previous video. So that is okay. So I will show you that. So here in the second B part question is this, and here the two conditions of alternating series test are satisfied, and we showed that this series convergent by alternating series test. Okay, in this example. Now we have to determine whether this series converges absolutely or converges conditionally. So for that we'll take solution. So sigma k equal to 1 to infinity modulus of minus 1 power k plus 1 k plus 3 divided by k into k plus 1. This series is actually is equal to k sigma k equal to 1 to infinity k plus 3 divided by k into k plus 1. Now we will use limit comparison test to show whether the series is convergent or not, convergent conditionally or absolutely. So for that I'm take ak is equal to k plus 3 divided by k into k plus 1 and bk 1 by k. So we already know that sigma k equal to 1 to infinity 1 by k diverges by p series test. So now we will take limit k tends to infinity ak divided by bk. So this is equal to limit k tends to infinity k plus 3 divided by k into k plus 1 divided by 1 by k. So this k and this k get cancelled. So this is equal to limit k tends to infinity k plus 3 divided by k plus 1, which is equal to limit k tends to infinity 1 plus k by 3. K take k outside, 1 plus 1 by k. So this is equal to 1. Therefore, limit k tends to infinity ak divided by bk is equal to 1. A finite quantity is finite, then by limit comparison test, then by limit comparison test, sigma k equal to 1 to infinity ak diverges because sigma bk diverges. Okay, therefore sigma k equal to 1 to infinity k plus 3 divided by k into k plus 1 diverges. Thus sigma k equal to 1 to infinity minus 1 power k plus 1 k plus 3 divided by k into k plus 1 converges conditionally, or it's a conditionally, or it is a conditionally convergent series. So now, so now we will discuss a ratio test for absolute convergence. So this test is very important because this test actually shows that if uh, because this test shows that if it is not conditionally convergent, that means it's not absolutely convergent, and if and this uh, and it also tells us whether the series divergent or not. So not absolutely, but it's divergent or not. So ratio test for absolute convergence. Let the sigma uk be a series with a non-zero terms, and suppose rho equal to limit k tends to infinity mod uk plus 1 divided by uk. If rho less than 1, then the series sigma uk converges absolutely and therefore converges. So series converges absolutely, then it's obviously convergent. And this is the important part. If rho greater than 1, the series diverges. That means the series may not be conditionally convergent. That means the series is divergent. And if rho equal to 1, there is no conclusion. Okay, so we will do a problem. So use ratio test for absolute convergence to determine whether the series converges. So the first problem is sigma k equal to 1 to infinity minus 1 power k 2 raised to k by k factorial. So taking the absolute value of the general term uk, we obtain mod uk is equal to mod minus 1 power k 2 raised to k by k factorial, which is equal to 2 raised to k by k factorial. Now rho is equal to limit k tends to infinity mod uk plus 1 divided by uk, which is equal to limit k tends to infinity 2 raised to k plus 1 into k plus 1 factorial into, we take a reciprocal, k factorial divided by 2 raised to k. So from here, we will get 2 and k plus 1 k factorial, that is k plus 1. So this is equal to 0 as k tends to infinity, and this is less than 1. Therefore, the series converges absolutely. Therefore, the series converges. Now, for the second problem, sigma k equal to 1 to infinity minus 1 power k, 2 raised 2k minus 1 factorial divided by 3k, 3 raised to k. So taking the absolute value of the general term uk, mod uk is equal to modulus of minus 1 power k, 2k minus 1 factorial divided by 3k. So that is equal to 2k minus 1 factorial divided by 3 raised to k. So if I take rho equal to limit k tends to infinity mod uk plus 1 divided by uk mod uk, which is equal to limit k tends to infinity 2 into k plus 1 minus 1 factorial divided by 3 raised to k plus 1 into, we will take reciprocal of uk, 3 raised to k divided by 2k minus 1 factorial, which is equal to limit k tends to infinity. I will get this 3k and 3 get cancelled. So there is 1 by 3 into 2k minus 1 factorial, uh, 2k plus 1 factorial divided by 2k minus 1 factorial. So this is equal to 1 by 3 into limit k tends to infinity 2k into 2k plus 1. This goes to infinity. So rho must be greater than 1. Therefore, this series is divergent. So that is the importance. So the series directly diverges, not it is divergent. Okay. So that means the series is not conditionally convergent.